How and when did our universe come into existence? Is there an alternative universe? These questions have been debated for centuries among physicists and astronomers. Everyone had their theory to explain based on their observation of the universe. But we don't have an absolute and indisputable explanation for this. Today, in this video, we will discuss the mysteries of the universe's origin and theories about the multiverse, the existence of another universe. Mankind has always been eager to know the structure and origin of the universe. Let us go through the history of how things evolved and how discoveries were made about the origin of the universe. Earlier, the universe was considered static, assuming Earth at its center. Later, it was discovered that the Sun was at the center. Then, it was portrayed that the universe consisted of the Milky Way galaxy, and that the Sun was the center of this galaxy. Static means no change. It simply means that the universe was, is, and will be the same tomorrow. When we dig into history, the idea of a static view of the universe can be traced back to ancient Greece. It came from the famous philosopher Aristotle. Aristotle's idea was geocentric. This means he assumed that the Earth was at the center of the universe. Moon, sun, planets, and stars revolved around the Earth. In the 12th century, Thomas Aquinas incorporated Aristotle's theory and proposed that God created the universe out of nothing. In the 14th century, a Polish astronomer, Nicolaus Copernicus, proposed that the Sun was at the center of the universe. Followed by this, in the 16th century, a German astronomer named Johannes Kepler discovered that the orbits of the Sun and its planets were elliptical. Later in the 17th century, Sir Isaac Newton, the famous mathematician and physicist, gave calculations about the terrestrial and celestial motion of the planets in the orbit by using the law of universal gravitation and the laws of motion. These Newtonian laws projected the universe as a huge machine, and all the objects in the universe followed by the universal laws and were in harmony. Based on Newton's theory, the French astronomer and mathematician Pierre-Simon Laplace developed the nebula hypothesis in the 18th century. The hypothesis presented a physical explanation of the origin of the solar system. He proposed that space particles in the orbit of the Sun condensed and formed into planets. At the end of the 18th century, William Herschel proposed the idea of the Milky Way galaxy by counting stars in all directions of the universe. During the same period, a German astronomer developed the measure to count stellar distances. After development to measure distances, it became quite easier to discover more about the universe. It helped to discover Alpha Centauri, the nearest star, with a distance of 4.3 light-years. After many centuries, at this point, astronomers believed that the universe is gigantic and began to explore the origin of the universe. At the beginning of the 20th century, astronomer Harlow Shapley started studying clusters of stars. He discovered that the Sun was not the center of the Milky Way, and that the Sun was around 30,000 light-years away from the center of the Milky Way galaxy. He also discovered that the Milky Way galaxy was 120,000 light-years in diameter and 1,000 light-years wide. With the development of new observation techniques in the 20th century, the view of the universe changed. In 1917, the 100-inch telescope was launched at Mount Wilson. Then, such advancements continued. Radio telescopes in 1940, X-ray telescopes in 1949, ultraviolet telescopes in 1968, and infrared telescopes in 1983 were introduced. With the help of all these high-end telescopes, scientists were able to observe the most distant galaxy, which was estimated to be 13 billion light-years. After studying the atomic composition of stars and the process formation of stars and galaxies, the Big Bang Theory was initiated. The Big Bang Theory is currently one of the most acceptable theories by scientists. Scientists observed that other galaxies were moving away from us at great speed in all directions, just as an explosive force propels any object away from itself. It was first suggested by a Belgian priest named Georges Lemaitre in 1920. His observations proposed that the universe was formed from a single primordial atom. This idea of Georges Lemaitre was accepted by astronomers, as it was in line with Hubble's observations of galaxies moving away from us. In 1960, two astronomers, Arno Penzias and Robert Wilson, discovered cosmic microwave radiation. This led to the interpretation that the moving away of the galaxies was the aftereffects of the Big Bang. Further observation and study by the scientists in this direction helped them discover and understand the intensity of the Big Bang. It was observed that in the first 10 raised to minus 43 seconds of the Big Bang, the universe was less than a billionth part of a single atom. It was believed that gravity, electromagnetism, and the strong and weak nuclear forces forged into a single force and led to this expansion. But scientists were still not able to figure out how this unified force worked. This led to the discovery of breakneck expansion, or cosmic inflation. These observations explained the reason for the universe having an even temperature and distribution of matter. The Big Bang theory further explored that the expansion of the universe was at a slower rate after inflation, but still, the cause of inflation wasn't known. After the cosmic inflation, with time the matter cooled and condensed. This led to the formation of stars and galaxies, which we see today. Further, the Big Bang theory suggested that during the initial second of the Big Bang, the universe cooled enough and provided the circumstances for the four fundamental forces to separate. From the inception of the Big Bang, the universe has been continuously expanding. In the early stages of the formation of the universe, the radiation was very intense. Colliding photons formed pairs of particles made matter and antimatter. It is believed that as the universe cooled, photons no longer had enough force to make these pairs, leading to annihilation. Out of this, some excess matter survived, forming stars, planets, galaxies. This doesn't end here. As we found that the universe was expanding, it led to another question. Are there other universes, similar or parallel to us? It was termed as multiverse. In the 1980s, Stephen Hawking and James Hartle proposed a new theory explaining the emergence of the universe from nothingness based on quantum mechanics. Based on the rules of quantum physics, they proposed that the Big Bang was capable of creating an endless supply of universes. It was based on the idea that the configuration of particles in a Hubble volume takes place multiple times. Hartle-Hawking's theory suggested three assumptions. Number one was that there might be other universes with Earth-like planets, societies, and even individuals, just similar to our universe. Another assumption from this theory was that other universes existed with Earth-like planets where dinosaurs were still living. And lastly, there would be universes that will be completely different, no stars or galaxies, and might have different laws of physics than this universe. Let's discuss what were the observations and research that led us to these questions. In the late 90s, these discoveries denied the fact of the Big Bang, that the universe was filled with particles, antiparticles, and the radiation that caused the Big Bang. After years of observation and research, the cosmic inflation theory proposed that our space was filled with energy. This energy caused the space to expand at an exponential rate. Later, when inflation ended, this energy converted into matter and energy. This added fuel to the ongoing Big Bang. In other words, the Big Bang that started billions of years ago was a continuous process and still ongoing in the unexplored parts of the universe. According to NASA, the universe underwent rapid expansion in a very short time. The cosmic inflation of our universe ended 13.5 billion years ago. The universe that we see is just one part of this region where inflation has ended. The parts of the universe that are beyond our reach might have other regions where inflation is still in progress. That's what cosmologists call the idea of the multiverse. This idea is based on two widely accepted aspects of theoretical physics. One, the quantum nature of everything. Two, the properties of cosmic inflation. On the contrary, we are incapable of measuring it, just as we are not able to observe in Hubble's space the unobservable part of the universe. If we accept the idea of both cosmic inflation and cosmic physics theoretically, then we have to admit that we are living in the multiverse. Unlike other mysteries of the universe, this theory also remains unsolved, and we can't test them. After hearing all these theories and observations, we can come to a simple conclusion that the multiverse is not a scientific theory. Instead, it is a theoretical assumption based on our interpretation of the laws of physics. According to string theory, neither we can explain anything until we have observed, nor do we have anything definite that we can look for. In other words, Unless we have complete data, we will be unable to come to some valid and scientific conclusions about the multiverse. After all, these are just assumptions, and assumptions are not science. Science requires valid observations and absolute values. Until then, these theories are just wishful thinking. Therefore, the multiverse is a scientific prediction, based on assumptions that might be proved right or wrong with the further advancement of science. If you enjoyed this video, don't forget to like and share it with your fellow space fanatics. Hit the subscribe button for your weekly dose of informative fun, and ring the bell icon to never miss a video from us.